This is the homework for 333, 334, and 335. For problem 333, examine the rectangle and then write an expression for the perimeter in terms of x. So for perimeter is the length of all the sides, or the sum of the length of the sides. So here we have 2x, and opposite sides of a rectangle are congruent. So if this is 2x, this is 2x. And then we have x plus 3. So x plus 3, and the opposite side is also x plus 3. And so the perimeter equals side plus side plus side plus side. So now we're going to go ahead and add the length of the sides. And here I have 2x and 2x plus x plus x. These are like terms. They're all x's. So I can combine those like terms, and then I have 3 and 3. So 2x plus 2x is 4x, 5x, 6x, 3 plus 3 is 6. So the perimeter equals 6x plus 6. For part B, if we assume the perimeter is 78 centimeters, we need to determine the dimensions of the rectangles. So if we know that P equals 78, so perimeter equals 78, we plug it in and we can go ahead and solve for x. So now if P equals 78, we plug it in to the equation, perimeter equals 78. So here we have 78, and we're going to solve for x. Inverse property of addition is subtraction, so we subtract 6 from both sides, 0 pair. 78 minus 6 is 72. Inverse property of multiplication, this multiplication is division. We divide by 6 because that creates the giant 1. What you do to one side, you do to the other. 72 divided by 6 equals 12, so x equals 12. Now what we can do is plug it in to the terms that we had for each side that represents each side. So the length of this is 2x, so x equals 12, so that's 2 times 12 is 24. The length of this side was x plus 3, so if x equals 12, 12 plus 3 is 15 centimeters. Part C, we want to verify that the area of this rectangle is 360 square centimeters. So remember, the area of a rectangle is length multiplied by the width. So we have the length multiplied by the width. So we have 2x multiplied by x plus 3. And we know that the value of x is 12 from the previous problem. And so now we have 2 multiplied by x, which is 2 multiplied by 12. And x plus 3, 12 plus 3, is 15. So now we have 2 times 12 is 24. 12 plus 3 is 15. 24 multiplied by 15 does equal 360 square feet. Problem 334, write an equation for the tile pattern represented at right. So we have the tile pattern here, and we have a graph here. So for figure 1, there are 2, 4, 6, 8, 10, 11 tiles. Here we have for figure 1, 2, 3, figure 3, there are 1, 2, 3, 4, 5, 6, 7. There are 7 tiles. So what I did is I plugged that into a table. And there are many ways of solving this problem, but this is just one of the ways. And so I plugged it into a table. Figure 1 has 11. Figure 3 has 7. And then I recognized that its tile patterns grow at a constant rate, so I knew from 1 to 3, halfway between 1 and 3 is 2, and halfway between 11 and 7 is 9. So I saw the pattern that it's decreasing by 2 tiles for every one figure number. And I was able to go ahead and fill in the rest of the table. And if I went to the to the left, I'd be increasing by 2 for every one figure number I'm decreasing by. And so I was able to get figure 0. Figure 0 is important because that is the y-intercept. So we have the y-intercept and we also have the rate of change. Difference of the y's over the difference of the x's. So in slope-intercept form, y equals mx plus b, we have the rate of change, the difference of the y's over difference of the x's, which is negative 2 over 1. And then the y-intercept, what you start with when you're at figure 0, when x is 0, y is going to equal 13. So the equation for this tile pattern is y equals negative 2x plus 13. It has a negative slope or rate of change because as you increase the figure number, you're decreasing the number of tiles. For number 335, we need to estimate how many times heavier a flying fox is than a bumblebee bat without using a calculator. So they had some distractors in here, which was giving the wingspan of each of the animals. And that is not important because we're just talking about the weight of each of them. So here's the weight of the hognose bat in scientific notation and the weight of the golden crown flying fox bat. And we want to know how many times heavier. When you see that, a lot of students think it's multiplication, but what you're doing when you're trying to find out how many times heavier, you're actually dividing. And so I have the golden bat, the giant golden crown flying fox bat, so I'll just call it the fox bat, and the hognose bat. And I'm going to go ahead and divide these two. And there are many ways of doing it, but I just put this one in scientific notation. 1 6/10 multiplied by 10 to the 0 power. Anything to the 0 power is going to be 1. So if I'm multiplying this by 1, I'm not changing the value of this. So, but it is now in scientific notation. Now I can go ahead and divide 1 6/10 divided by 2 equals 8/10. And then when you're dividing in exponents with the same base, it's division. So, you're going to subtract them. You're going to subtract the exponents. And we have 0 minus a negative 3, which is a positive 3. So now I have 8/10 multiplied by 10 to the third. And here's 8/10 multiplied by 10 to the third. And I'm going to go ahead and put it in standard form. And this is, I'm going to be multiplying it by a 10 with 3 zeros. And if this is increasing, this is a large number, this is going to increase. And so this is telling me how many times to move the decimal to the right, which is 3 place values, 1, 2, 3, and we get 800. So the flying fox is about 800 times heavier than the bumblebee bat.